Hey YouTube, in an upcoming video I'm going to be looking at an interesting relay logic problem, but before I can do that I have to cover the basics of relay logic. This is called a ladder diagram. Starting from the top rung and moving down, I have a push button in series with a coil labeled R1, a normally open contact R1 in series with a light, a normally closed contact R1 in series with a light, a normally open switch in series with a light, and a normally closed switch in series with a light. When we first apply power to this circuit, the normally closed contact R1 allows electricity to conduct through the light on the third rung. Also, the normally closed switch on the last rung allows electricity to pass through the last light. Pressing the push button on the first rung allows current to pass through the coil R1. This closes the normally open contact R1 on the second rung and opens the normally closed contacts on rung 3. This causes the second light to turn on. The normally open contacts related to a coil can be thought of as a non-inverting output. When the coil is activated, the normally open contacts will become closed. Normally closed contacts act like an inverting output to a coil. When the coil is activated, the normally closed contacts will open. The switches on the last two rungs do not change state. This is because they rely on an outside action in order to be activated or deactivated. The circuit pictured here is a basic latching circuit. It is very common in motor control and is an easy way to turn a momentary input into a maintaining input. When power is first applied, no current can pass through the circuit. Pressing the push button on rung 1 allows current to pass through the normally closed push button and the coil R1. This in turn causes the normally open contacts R1 on rung 2 to close. Once the push button has been released, power continues to pass through the normally closed contact R1 and through the coil R1, turning the momentary push of the push button into a maintaining signal. In order to deactivate this circuit, the normally closed push button can be operated. This breaks the flow of current to coil R1 and causes the normally open contacts R1 to open. By using different arrangements of coils, normally open and normally closed contacts, it's possible to make any logic gate, including AND, OR, XOR, or NAND gates. By combining these gates, it is possible to make complicated control hardware. I hope you found this interesting. In part 2 of this video, I will be applying what we learned here to update an existing circuit to meet a new set of specifications. Thanks for watching.